Right. So this is the thing that we have done last time, MPLab example. So first of all, we need to set up the constants. So set up the constants means we have to define our register. So 03H we have status register, at 85H we have this A, at 05H we have port A, and count 1 and count 2. These are two general purpose registers of PIC16 F84. Right. So therefore, why we set up this, we are equating this known values, status, say, port A, count 1, count 2, to these registers, because then it is easy for us to use, right? So then what we are doing in here is, in our program, is LED blink. That means the LED should switch on, then there should be a delay, then afterwards it should switch off, then there should be a delay, then again it should continue by switching on, delay, switch off, delay, switch on, delay, so like that. So therefore, first of all, we need to switch this on. And before switch it on, we need to make our port A as what we call an output. So we have to configure the port first. So therefore, what we are doing is, we will go to bank one, right? Bank one. Then we will put this literal value to 0, 0, 0, all zeros to W register. Then from W register, we need to move it for this A, right? So why we are doing this is because we cannot directly move to we cannot directly assign values to this A register, right? So therefore, now this A has all zeros, right? That means our port A, which has 5 pins, it is configured as output. Then we need to work with our port A. So therefore, we will come to status register, and then we will clear the bit number 5 of the status register. So that what it makes is, it will make our it will change us from, it will jump from bank 1 to bank 0. So now we add bank 0. Why? Because port A register is at bank A, bank 0, right? So then we need to turn on the LED. First of all, what we are doing is, we will we will in here, you can see I have put a label. So we will put 0 to H, right? That means we will write 0 to H. 0 to H means 0, 0, 0, 1, 0, right? So this is RA0, and this is the pin, this is the value associated for RA0 pin, and this is the value associated for RA1 pin, right? So therefore, we will put value 1 to RA1, or bit number 1. This is bit number 1, right? So this bit number 0, so like that. Then we will move that value to port A. Can you see? We will move that value to port A. So therefore, what we are doing is, now our port A, it has a value. So 0, 0, 0, 1, 0. That means RA1 pin is at high. So therefore, after, so now our LED switch on. So afterwards, we need to have a delay. So therefore, if you can remember, so this is our delay loop. Delay loop in here. In here, we are using 2 counts. So loop 1. So this is the label. So we will decrease the count 1 value from 255. So the default value of count 1 is 255. We will subtract it. So when it reaches to 0, right? So this will go like this. So go to loop 1. So it will go to here. So until it reduce from 255, we will go in this loop, right? But so what this command says is, decrement if 0 is skip is if 0, right? So skip means if the value has returned to 0, what will happen is, it will skip this line of command, then it will go to this line of command. right? So afterwards, what will happen is count one will be resetting to 255. Right? So here we are in here. So again, we will go in this. Again, we are going to go in this loop. So after this one, it will execute this line. So that means again we are going in here. Right? So therefore, 255 into 255 times we are going in this loop. Right? So this is the delay loop that we have after switch on and before switch off. Right? Then we need to switch off. So therefore, in order to switch off, we will move here 0 0, and that means all zeros to W. Then we will move this all zeros to port A. Right? So now port A, all pins are at 0. That means RA1 pin also at low position. Right? So then afterwards we have added another delay, right? Another delay like this. So that delay is, yeah, we are using like loop 2, but we are using same count 1 and count 2, because after this they have reset it to 255. So we are at here. We are at here, right? So after switch off, then there's a delay, right? So after this delay, what we need to do is we need to make this keep on happening. It is blinking. So therefore here I have added a label called start. So then go to start. So this thing will happen uh, as a loop like this, right? So this is what we have learned, and if you can remember after, so this is .asm file, right? Assembly file .asm file. So after we executed this one, after we have opened this one in MPLAB, and after we executed this one, what you will get is a hex file, right? A hex file, and after that, what you are doing is you will put that hex file to um, Proteus, right? Proteus. So then after that, you will put that onto the Proteus simulation. So that's what we have done, right? That's what we have done. So after putting that um, in there, right? After putting that in there, we just need to run the program. So therefore, the Proteus file, Proteus will read our .hex file. So then it will execute. So .hex file means the way that the machine can, or processor can understand. So then that's what we have done with MPLAB IDE. Right. So by just looking at this one, it is somewhat complex. Why? Because we are going to the lowest level. So even we are assigning, we are going into the register level. Can you see? And in a command like this, we are going into the bit level. I see we are going into the bit level in here. So therefore, so here you can see that when we are doing it in MPLAB or in assembly language, um, this is a lot of complex. So we are addressing in register level, and also in here we are addressing in bit level, right? So we are going into the bit level, right? So this is somewhat hard when we have like complex program, right? Complex program to be done. So therefore, what we are using actually something called, as I told you, Micro C Pro, right? Micro C Pro for peak, and so in here, right? Right. So Micro C Pro. So then for peak, that is what we are going to use today, right? So first of all, I will show you what is Micro C Pro. So this is Micro C Pro. Okay. So this is Micro C Pro, and you can see after you install it, this is what you should see. Micro C Pro. So now what we are going to do is this, right? We'll start a new project, right? So we'll put LED blink, right? Then we will browse. Okay, so we'll make a new folder. Example one. Right? Here, if you want, we can adjust the device clock as well, right? So we will just it to 16. Okay, 16. Then go next. So if you need to add more files to this, we can add from here. But since this is our first one, so we will to next, right? So then hit task include library. So I will put in. Okay, I think you can see this, right? Are you following me? Yes, you're following me, right? So here, so this is the first one that I have shown in previous one.
Excuse me, sir.
Yes, yes.
Sir, we can't see your screen.
Okay, give me a minute. Can you see now?
Yes, sir.
So
Sir, can you start from the beginning?
yeah, I can start. So I'll close this one. Okay, so new project, right? So LED blink, and I'll browse it for somewhere here. Then I will. Yeah, right. So project name LED blink, project folder. I have browsed it for some we need. So here device name we can select, right? So first I will select the project folder, right? I will put that example one. Okay, example one. So that is the folder we are selecting. Okay. Then I need to select the device. So it is PIC16F84. And then in here, if I need to change the device lock, you can change, but I will keep 8. Okay. Then go to next. So then if we need to add files to project, we can add
Sir,
files from here.
sir, sir,
Yes.
please wait.
Okay. Okay.
Sir, can you go back?
So this project folder, right? So project name I have put as LED Blink, right? So I have browse. Then this is where I have selected it, right? So lecture 6. So I have created the folder called example1. That then in here device name we can select. So if you type pick P16F84, you will get. Then here you can change the device clock, right?
Sir,
Yes,
මේ
please.
device name එක එතන type කරන්න බෑනේ sir.
Then can you just select? So then can you just scroll and select? Yeah, pick. Yeah, 16. That is C. So F. Yeah, 7 84084A. Yeah. I will say pick 16F84. In here we can type, right? Yes. For device clock we can type. This one you have to select from this drop down list. Yes.
Okay, sir.
Okay. So we'll forward as next. So here add files to project. So uh, if you want to add some files that previously um, written, so then we can do this, right? We can add it from here. But since this is our first one, we will just go next. Okay. So in here, this has include default libraries. So include some custom libraries a custom selection, but we will ask to include all libraries, right? Then we will put finish. So, okay, so then see, so this says like LED blink dot C, right? Right. So then can you see that in here we have void main means, so inside this we need to write our code. Okay. So then we will just try to run this here. We have build current project, build all open projects, and build and program. Okay, so and start program, but here we don't have a programmer, so I will just put like build, right? So let's see what will happen. So here this says, so even though we have created the project, so it is asked to save, right? This asks us to save. So here I will save it as like LED blink, right? LED blink. I will save it as this. So save type as C file. So like this, I will just say. So if you check, you have saved it, right? So here this is what you should see inside the folder. I see. So this is what you will see. Here this is the assembly file, and here we have the hex file here in text document. So if we just open it, we just open this one, assembly file. So here can we see LED blink. In here we have just void main. Inside this we have just void main, right? So this is what we have created, right? So I will show you again. Right, I will show you again. New project, browse. In here I will create like sample one, right? So I will select that. Then okay, right? So I have selected the pick. So again, what I have done is, yeah, I have selected. I have closed everything. Then I have deleted that folder. Then I have created like example one folder, right? So then I will start it again. So next, finish, right? So then you can see, so this is where I have share. So this is where I have created the folder. So can you see inside this example one, this is what we have, right? LED blink. Okay, LED blink. So this is mhm. This is what we have, right? This is what we have. Then again will come here, right? Then I will try to build, right? So then this asks, right? This asks to save this. So I will save it as LED blink. So still, if you check there will be like few files created, right? Put it as, let's say, so if you check, can you see the other files? Yeah, this is the assembly file. It has name like this, but yeah, you have this X files and everything. This is for this project, right? So what the project that we are doing in here. So here this is the assembly file, right? Then so now it is saved, right? So now this is what we are going to do, right? So I will like here void main. So inside this I need to write it. Okay. So what I'm going to do is here tris a. I will put as tris a equal 0. 0 means what? This is 0, right? 0 means everything in tris a, it is 0. So why we need to make this? So do we have to define here? We don't have to, right? Why? Because when we type like tris a, the program this compiler micro C, it will identify that is our tris a register, right? Then for port A, right? So for port A, I will put like 1. That means so to switch on, right? Then I need to have delay, right? So here there's a function called delay ms, right? So then constant unsigned long time in milliseconds. So milliseconds time we need to put, right? So I will put like milliseconds. How many milliseconds? 500 milliseconds, right? Then after that I will put port A equals 0. So here when port A equal 1 means, so this is not all ones. Can you understand? It is not all one, it is 1. In decimal value it is 1. That means see, for port A there are 5 pins, so 0 0 0 0 1, right? What we have is 0 0 0 0 0 0 0 1. Then I have to put another delay, right? Delay in milliseconds. Again I will put like 500, right? Then we try to build this. So here it says like finished successfully, right? So then what you have to do is you have to open Proteus. So can you open Proteus? Open Proteus. Then can you set up? For this one? So connect an LED to port a RA0 pin and RA0 pin. Then ground it through a resistor. So then put that hex file into that. Then can you try to um, run that program? So see what is happening. So did you try it on Proteus? What is happening? Right. So here, then what you need to do is, so here you have to open port yes. Then you need to pick 16F84. Right. Then LED. So RA0 we need to connect. Then we need resistor, right? So we will put here and ground. We can connect this. So if we try to run this on here, program property not specified, real-time simulation failed to start. Why? Because we haven't put our file into this X file into this. So therefore what we need to do is double click on this one. So if you can remember, we put the clock frequency as 8, so I will put in 8. Then program file, so where we have our program. So if we check it, 46 delivery. This is example 1, right? Here can you see this X file, so I will open that. Okay. Then the simulation is already stopped. Then if we run this, okay, so stop. Okay, here this resistor is 10K.
Excuse me, sir.
Yes,
Resistor
yes.
ගත්ත විදිහ
Yes.
resistor ගත්ත විදිහ පොඩ්ඩක් පෙන්නන්න.
Components kind of thing, right? Yeah. So we take component. So this is component. So P in here just type res res. So then you can see. So if you double click, it will be appearing on this and the pane at the left hand side. So now it is 220. Okay. So 220 or 330 we have to put. Then if you run it, can you see that it is switching on and switching off? So what is missing in here? You see it is switching on and then switching off. So what is missing in here? Can you see that when we run it, so check in here, yeah, RA0 pin, stop. RA0 pin, can you see that it is the only value that is at red color? Why is that? Because that is where we put our value 1. So value 1 means 0 0 0 0 1. Right? So that's why. So can you so by the knowledge that you have, can you try to fix this? So there's some error in here, right? What is that is you can identify what is the error, that this should continue, right? This should continue switch on and switch off. So that is what meant by LED blinking. So here this will just blink once. Okay, switch on then off, right? So this should continue. So can you try to solve that issue in your program? So what we should be doing in here, so it should run continuous, right? So in order to do that, what can we do? You first try this one, then you can go for that.
excuse me sir.
Yes.
සර් රන් කරපුවාම RA1 පින් එක මේ මොකද්ද නිකන් බ්ලින්ක් කරනවා නේද රෙඩ්
RC,
බ්ලූ වගේ
RC0 නේ.
RA1 පින් එක තමා ලින්ක් වෙන්නේ
දැන් ප්‍රෝග්‍රෑම් එක මෙහෙම ලිව්වොත් පෝට් මේ පේනවනේ. පෝට් A1 කියන්නේ මේක ඇත්තටම ලියන්නේ 00 1 කියන්නේ ඩෙසිමල් 1 මේ තියෙන අපි. So if you put 2, let's see. Then okay, then here this RA1 pin should blink like this. See, can you see? Okay, so I have done this. So from here in this, then if I run this, so can you see RA1 pin? It is blinking, but here since we haven't connected our LED to that, it will not appear, right? But here can you see that RA1 pin is switched on. So that's because this is 2. 2 means 1 0. 1 0 means RA1 pin is at 1, RA0 pin is at 0. So we'll put 1. Then we build this, right? So it is built in. Then we go to Proteus. So then in Proteus we need to again select it as I remember. So open. So can you see now RA0? Okay. So what should happen is we should continue blinking this switch on, switch off, switch on, switch off, right? And if we compare see this. So this is so from here, this will not run, right? I have included this one here. Can you see? This is our assembly language program. Can you see how many lines that we need? At least here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, 19, 20, 21, 22, 23, 23 lines. But here we just written this one, 1, 2, 3, 4, 5 lines. Right. So for the assembly language one, we need more than 20 lines in order to write the same thing. And also again, if we don't have the facility of adjusting this one, but we have to use other registers and everything. But in here, the same thing will happen, right? But it will not be seen for us. So that's why we are calling this as high level programming language, right? So this is low level because we are addressing even in bit level here. This one, yeah, addressing at bit level. Let me see. Right, so few and just this one is 1000 built. Okay, this is running. So here can you see that now the delay is increased, so therefore like this, right? right? In here, can you see like this? So if we want to see the assembly of this one here, we can see it from here, right? View in assembly. So here can you see? So this is in assembly. Okay. We can see the assembly commands. Can you see? LW, move, WF. So everything we can see. So what is missing in here is this should continue, right? So how can I do that? Yeah, this is inside the main, so therefore we can let's say for loop, right? For loop without any arguments. I will put a for loop, right? Okay, we can run this. Right, so you see what I have done. Yeah, I have put for loop. So this for loop, right? I'm doing it without any arguments, without any values. Right? Then I will build it, right? Then let's try this again. And if I run this, yeah, switch on, switch off. Then again switch on, switch off, switch on, switch off, like that. This will go. So can I try to do this as well? So I'm getting the same thing. Okay, so then uh, so as an example, when you do this blink an LED connected to RB4 pin. Can you do this? So blink and LED connected to RB4 pin, right? So blink and LED connected to RB4 pin, right? Give me a minute. So can you do this? Okay, so have you finished with this? So you have to change this as well. Also connected to RB4, then you have to write it for this port B.
excuse me sir.
Yes.
සර් අපිට අර ලාස්ට් වීක් වල ලෙක්චර් නෝට්ස් එවන්න පුළුවන්ද?
මං එකක්වත් දැම්මේ නැද්ද ඔයාලට? හිතලා
ලාස්ට් වීක් එක ආවේ නැහැ.
හරි මම දානවා. So can you do the changes in this one? So then you need to put that file in here.
excuse me sir.
Yes,
සර්
yes.
අපිට පුළුවන්ද මේ අර අපි ලියපු කෝඩ් එකම ආයේ රීරයිට් කරලා මේ කියන්නේ වෙන පින් එකකට මේවා කරලා ඊට පස්සේ LED දෙකක් ලින්ක් කරන්න.
ඔව් එතකොට දැන් ඔයාලට ලියන එකේ එතකොට ඩෙසිමල් වැලියු කට දාන්න හැකි. උදාහරණයකට ඔයාලට මෙන්න මේ ලියලා තියෙන එකෙන් බලපුවොත් RA0 RA1 පින් දෙකට LED දෙකක් කනෙක්ට් කරොත් එතකොට මෙතන 1111 කියන්නේ 3 port A එකට 3 දුන්නා නම් හරිනේ. හරිද? port A එකට 3 දුන්නා නම් හරි.
Okay, sir.
So in this example, so if you can do it for like RB4 and RB3 both, RB3 and RB4 and RB3 both can you do? Okay, so RB4 and RB3 pins. So select and delete. Connect it to RB3 and RB4. Yeah, either we can connect it in here, but when that comes, it will be in series, right? So therefore, I will add the resistance. This then yeah. So what should happen is crispy make everything output port B. So what we should have is 0. How many zeros that we have? 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. Right. So here this is RB0, RB2, 1, RB2, RB3, and 4. So 1. That means here 0, 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Right? 2 to the power 3 is 8, and 2 to the power 4 is 16. Right? So therefore, it's 10K. Right? This is switch on and off. Okay. So in here, when you are making a project, so it should have the same name, and here we have to put this because we say that this is the end of this line, right? Yeah. So from this one, from statistics, so can you see that the SFR locations, everything that you can see it from here. So from memory usage, so 969 program words, 54 program words are used. So total 1023 program words that we can use. Then yeah, the statistics that we can see. Okay. So here these are the basic libraries that we have. So everything that we are using here, delay MSIs, this is a PS written program, so we are passing the argument, so therefore we will return the delay, right? Like that. So with that one,